Today is Thursday, February something, 25th. Okay, we're almost to the end of February. That's kind of fun. That's good. That means tomorrow's payday. That's always good. So today we're doing the lab, and we're going to be determining the percent oxygen in KClO3. Now, when you're reading over this, okay, it gives the equation that KClO3 solid when heated, and in our equation, if you just put a triangle over the arrow, that's going to imply heat. Okay, you can write the word heat if you want to, but just the triangle, it's kind of like a scientist that can't draw like me, that's their flame. Okay?
Can we write on those?
Yes.
Okay.
All right. Then it goes to KCl solid plus oxygen gas. Then you have to balance it by putting a 2, a 2, and a 2. And what we're going to learn is what type of reaction do you think this is? Well, not in terms of that, in terms of different types of reactions. We haven't covered it yet, but I was hoping that maybe you remember from 8th grade. This is a decomposition reaction. So, if we heat this up, what's going to happen to the mass? It's going to go up, down, or stay the same? Now, if we did it in a closed container, it would stay the same. But we're doing it in an open, because oxygen's a gas, so it's just going to be going up. We're going to breathe it in. Okay? So we'll have a little bit of an oxygen high. So how can we get what's percent mean then?
Fraction.
The fraction or the part over the whole, right? What part are we interested in this lab? The oxygen, right? So we're going to measure, so we just said, how can we get the mass of the oxygen?
You just divide you divide like the part from the whole.
Okay, no, but how do I get this part weight? How do I get this mass?
Subtracted from the total.
For how much it goes down by, right? Because this is still a solid, so it's still going to be in our crucible. Okay. Now again, we just started out. Where have you heard the term crucible? That wonderful novel is American literature, right? It was written by an American.
Written by somebody.
Yeah, I'm sure it was written by somebody. That's it. I pretty much know that. Okay, but the classic book, The Crucible, and that was about the witches. Okay, and what did they do to the witches? They hung them or burned them. Okay, how do you know she's a witch? I probably shouldn't even recommend the movie, but Monty Python, that's what. How do you know she's a witch? Anyway, there's a whole funny scene about that. Anyway, so what were they trying to do in Salem? Why were they, quote, hanging or burning the witches?
Put them under pressure so they confess. So if they could take their land though when they kill them.
Okay, but what was the given reason? To purge, to purify, right? Crucibles are used to purify. They use high temperature to put pressure, but if you want to purify gold, you put it into a crucible designed for extremely high temperatures. They heat it up, the gold melts. Gold is extremely dense, therefore all of the impurities, the dross, rises to the top. They can scrape that off, and then you have the pure gold. It's purification through heating. Crucibles are designed for high heat to handle the pressure. Okay, so the crucible is a way of purifying. That's where the name comes from that book, is just using you quote the fire to purify the community, so to speak. Now we know because of human nature that really wasn't the purpose, but that's what we give the reason. So we're going to put this into a crucible, and when we get into the lab, I'll show you what the crucible is, but it's just going to be made out of, it's ceramic, okay, it's like, clay that's been fired. So it's designed for high temperatures. So we're going to just put the KClO3 about 2 grams. Now, what does the law of definite composition say? Will the percentage of oxygen change if you use 1 gram, 2 grams, or 3 grams?
No.
It's going to be the same percent, right? The ratio of grams of oxygen to the whole thing is always going to be the same, law of definite composition. So, 2 grams just is a good workable amount to get into the crucible. But if you get 1.95 or 2.05 or anything like that, we're just getting about 2. Just make sure you're recording the exact mass. Now we will need the mass of the crucible in the cover. So you're going to weigh it empty, and then while it's on the balance, just add until it gets about 2. Now you're going to have to do some mental math. So if it comes out to 25.1 for the mass of the crucible, you want 2 grams, you're going to have to take it up to 27.1, okay? I think you can handle that. All right? So, we're just going to follow the directions. Now, how are we going to know when all the oxygen's gone?
When it stops.
Stops dropping. So we're going to heat it for 10 minutes. We're going to always let it cool because there's the metal pan, but underneath the metal pan on the balance is plastic. So you put a super hot crucible onto that, it's going to melt the plastic and melt the balance. Not good. Plus, the more scientific reason is, as it's hot, it creates convection currents, and you don't get the accurate measurement because the air is circulating so much around it. It actually messes up and gives you a little bit slightly wrong answer for that. So we're going to let it cool for 1 minute to 2 minutes. It doesn't have to be cool to touch, but it doesn't need to be piping hot either. Okay, so we're just going to let it cool for about 2 to 3 minutes till it's kind of getting there. You still don't want to touch it with your fingers because you'll burn yourself pretty severely. Okay, and we don't want that. Okay, so we're going to have crucible tongs, and I'll show you what those are and how to use those when we get into the lab. All right, so we're just going to do this. We're going to heat it up 10 minutes, let it cool, weigh it, heat it up strongly again for another 2 minutes. Let it cool, weigh it. If those 2 masses are close, within like 0.01, 0.02 or so, then you're done. If it still went down a significant amount, you have to heat it again for another 2 minutes strongly until you get a constant mass. That's when we know that the oxygen is completely gone. Okay? All right. Let's set them up, move them out.